Aloha and welcome. In this video, we're going to be talking about the comparable interface. So let's go ahead and look in Zybooks. We're going to be talking about the comparable interface as it has to do with sorting array lists. So we're going to take a look at some code here. And in our code here, we're using the collections class. And the collection class sorts an array list of primitive wrapper classes like the integer or double. Looking at the code here, you can see that we've got our function named, our class named array sorter. And within this, we've got our main, where we've set up a scanner. We're setting up essentially a constant of 5 called number of elements. We're going to go ahead and create an array list of integer. And this is remember that integer with a capital I, we're talking about the primitive wrapper classes here. We can't use the primitives themselves or an array. So we're setting up an array list of the primitive wrapper type. And we're calling it user ints, and we're setting it up here. Then we go down, we print out a prompt to the user to enter X number of numbers, which is going to be 5. Then we go ahead and we loop through and we go ahead and input all of those. We solicit the response. We put that then into our array that we have here, the array list. So after we've done that, we have 5 elements. Then we're going to call on collections and we're going to have it sort this for us. So it goes ahead and sorts it, and then we go ahead and print out. So we loop over the 5 elements and we print them all out. So if you had numbers like -10, 99, 31, 5, and 31, it's going to go ahead and sort it in ascending order for us from -10 all the way up to 99. And it does this using the comparable interface. Let's go ahead and look at some of the participation activities here. This is going to help you further understand how this works. So when we're looking at this, which of the following can be sorted using the collections class sort method? So as I mentioned before, it doesn't work on like arrays, primitive arrays. It's going to, over here as well, it's not going to work on primitives. So it's over here where we're using the primitive wrapper class. So keep that in mind as you're going through. And then which of the following statements will sort array list of double, which is again the primitive wrapper class, sensor vowels in ascending order. So we look at this, it hasn't really told you about it, but there is no sort ascending. There also, if you looked up at our example above, it only took the one input, so it only had one argument. So it's not this one here. It's not going to be this one too, because sort ascending doesn't exist. It's just your sort. But again, this has to be referring to an array list of a primitive wrapper type. So then over here in 3, the collection sort method can sort an array list of string objects in, is it alphabetical order, natural order, or alphabetical or reverse alphabetical order? Well, it doesn't say this, so you can't really be faulted for not knowing it, but alphabetical order, it can do this, but it's not only, this isn't all it can do. Then natural order is kind of the same thing. So what it is alphabetical or reverse alphabetical order using different methods. So there's a reverse order, and there's also the sort order too. So that'll get you either ascending or descending. So what if we want to make our own user-defined class type? Let's say we had, instead of double or integer, we wanted to create our own user-defined type. Well, luckily we can do something. We just have to make sure that we implement the comparable type here. So what we're going to do are the comparable interface. So as it mentions up here, we need to use the implements keyword that indicates that the class implements a particular interface by overriding all the methods defined in the interface. So for employee data up above, we'd say implements comparable employee data. And that's going to indicate that we're going to override the CompareTo method, taking an employee data argument. So the CompareTo is what allows it to know when you're sorting how to compare things of that type. So if we made up like a person, it has to know, okay, how do you compare people? So inside the CompareTo method, we're going to be defining, what makes a person greater than another person, not in a metaphysical sense, but like last name, first name, that kind of way. So anyway, the CompareTo, when you're saying compared to, and the argument for it is going to be another comparable. You're going to return a number, and that number is going to indicate if the comparable object is less than, equal to, or greater than the other comparable. And that's going to come by either being a zero, meaning that the two comparable objects are equal. You're going to have a negative number, meaning that the comparable object is less than the other one that you called as an argument. And then if it's a positive number, that means that the comparable object is actually greater than the one that you're trying to compare it to. So we're going to look at this, the employee data class that we talked about. So if we were to set up an employee data class, we would say public class employee data implements comparable, and then in our brackets there, we're going to say employee data. And then we're going to set up our private attributes here: first name, last name, employee ID, department number. So we set those up, and then we have our constructor, and the constructor takes those four different arguments, and then it goes ahead and assigns it. So it takes the four arguments that correspond to the attributes that we just defined, and then it assigns them all. So then we have to override our CompareTo for the comparable here. So we set a public int CompareTo. We're going to be returning an int, as we said, either a zero, a positive number, or a negative number. And we're going to be taking, as the CompareTo, we're going to be taking type employee data, so we're comparing it to something just like the object that we're in, and we're going to have, we're just going to call it other employee. So then we internally define full name, other full name, and then comparison value. And we're going to go ahead and we're going to say, okay, comparison value is going to be the department number compared to the other employee's department number. So what we're first doing is, in this theoretical class, we're doing a comparison, first of all, to see if these people are in the same department. And if they're in the same department, then, well, that's the code down here. If they're in the same department, then we're going to take a look at their name. So we say full name equals last name plus first name. And then we say other full name equals, and then we get the last name and the first name of the person that was passed in as an argument to get the same last name, first name comparison here. And then we say the comparison value equals the full name compared to the other full name. So if this is if one is greater than the other, if they're equal, it'll return a zero. If the current one is greater than the other one, we're going to be returning a positive, otherwise a negative. So then after all that, we're going to return the comparison value, and then we're going to override the toString here. So we're going to, this just prints out the last name plus the first name, their ID, and the department number as well. So then we get into the participation activity, and they're going to be testing your knowledge of comparable interface. So you look at this, so they give you employee 1, employee 2, employee 3, and they're going to really make you think here. So what does employee 1 compare to employee 2 evaluate to? So you look at employee 1 here, and then you compare it to employee 2. So if we're using the code up here, notice that department is the first thing that we compare. So if we're looking at 1 versus 2, we notice that they're in different ones, right? So number 1 is going to be greater than number 2 in terms of department. So it should return a positive number. So that should give us a positive number. Then if we look at what does employee 2 compare to employee 3 evaluate to, 2 and 3, we do note that they're not equal there. So because they're not equal, we know that 1 is going to be less than 2, so we're going to come up with a negative number here. And then what about 1 compared to 3? So when we look at 1, they're in this 2, this one also is in 2. So it does pass this part and gets into here. So then we're comparing the last name to the first name. So then we look at the last name in the first name. So last name comes first in this comparison. So Sims should come before Albin. So we're taking the first one, comparing it to this one. So wait a second. Let me keep this straight mentally. So with Sims compared to Albin here, Sims is going to be greater than the other one. So it should be, wait, positive number? Yes, positive number. So That's how that works. We're just, working on the compare to, and remember that however the rules are that you've set up in that compare to, that's gonna, when you go to compare them, you're gonna need to understand, like, how exactly is that done. So just make sure that your rules match what you want it to do. So now we get into sorting array list of a user-defined class type. So when we get back to our collections, which is the collection sort that we were talking about, we can now use user-defined class types in here. So um, because the collection sort method calls a compare to method on each object within the array list to determine the order and produce a sorted list, in the program below, the array of employee data elements that we created above, it's sorted by the statement collections.sort on employee list, which sorts employees first by department and then alphabetically by name, just like we set it up above. And when we say alphabetically by name, we're talking about the last name. So we look at the code that they've set up here. We've got public class of employee records. Then we go in here and we've got our main. So when we look at this, we're setting up the employee list. That's fine. We're setting up, let's see, the employee data, user command, employee first name, last name, employee ID, department number, all attributes of the employee. So then we get down to do. We're going to do a do statement. We're going to print out, okay, so we're telling them enter a command. You enter A to add an employee, P to print employees, and Q to quit. And then we take the command from them, and then we just do we call this a switch in other languages, but we say if the user command is equal to A, then we're going to print out first name. We're going to take in some input from them. We're going to say last name. We're going to take in some input, ID, take in that, department number, take in that. Then we're getting down to the employee data. So we're going to create a new employee here using the 4 pieces of information that we took in. Then we're going to take that employee data and we're going to enter that into our array here. We're going to put it into our array list of employee data. So after we've gone ahead and we just added one, so we would be doing this in a loop until the user command is not equal to quit. So we go back up and do all this over again. If we want to print it though, what we're going to do is we're going to go over here, we're going to sort the list. So we're going to sort the list using the collections class that we talked about way at the beginning here. And we can sort it because employee list, if we look at employee list up here is an array list of employee data. Employee data, as we did above, it's implementing the comparable. So we've got the compare to, so we can actually do a comparison on the department number and then the last name plus first name. So because we can compare it to each other, we can now get through and sort this whole thing. So then it sorts it and then it goes and it prints that all out. It prints all the different employees out. So this is just how we take our user list or our user defined class that extends the compare to interface, and now we can use this with collections. And it shows us an example here of adding people in and then getting a sort of it. And you'll see that it does sort first by department and then it sorts by name after that. Oh, Alan Turing, shout out. There we go. So sort employee elements using employee IDs. So let's see here. The sort employee elements using employee IDs. Okay, so you can change this around. So it says modify the employee data's compare to method so that elements are sorted based on the employee's department number, which we did before, and ID, employee ID. So that's a little bit different. So originally what we did was we sorted by the department ID and then we did the last name plus first name. But now it wants us to change that from department number to, I guess, department number and then ID. Specifically, employees should first be sorted in ascending order according to the department number first. Fine, it does it by ascending naturally. And those employees within the same department should be sorted in ascending order according to the employee ID. So what you would do is you would go in there, you'd look for the compare to. In here, we've got the compare to, and you're going to be looking at the so they're doing the comparison of the department numbers, so that's fine. But then here, instead of doing all of this, you're going to want to change this to, you're going to want to change this so that you're comparing the employee IDs. So you'd really be doing a comparison of employee ID to the other ones. Well, you just set it up as, I guess we take the hold on. Yeah, so since we're taking the other employee in there, we do the other employee's employee ID and that using dot notation. Then we do the same thing for up here. So yeah, you just compare that, and then you would run it, and when you run it, it should come up with everything here. But yeah, so notice here it does this, but it's not doing the proper ID. So if we were to go up here and we wanted to change this, let's go ahead and so the second comparison that we're going to do. So if the department numbers are equal, then we want to compare the IDs. So we're going to take the ID. So let's say this dot employee ID. Hold on. So comparison is going to be actually not the, well, we don't need to use the dot notation internally. So we can just say employee ID. I think this is what it is compared to um, other employee employee dot m wait no employee ID like this. After we've done this, we can take that and delete it, and I believe that should do it. So what we should see is 1 and 1, and then this we do 2 and 2, but it should be 201 and then 202. Let's see if that works. So when we run it, it's 1 and 1. Then indeed over here we've got 201 and 203. So it is doing it by ID instead of the last name, first name, yeah, because these are no longer like that. So that's what you should do. And then, yeah, you can answer your participation stuff here. The following statement sorts an array class called previous employees. Assuming previous employees it is an appropriate initialized array list of employee elements sort of previous employees. So go ahead, you can answer these on your own. This should be easy enough. Extending a base class and implementing an interface. So a class can both inherit from a base class and it can implement an interface, okay? So it doesn't have to be flat out or original. You can be inheriting at the same time you're implementing. So for example, you can do a public class employee data like we just came up with before. We can say it's extending person if we have a person class, and then we can implement the comparable of employee data off of this. So as it says here, a programmer may need to compare an object of a user-defined class to an object of a different type. So you can do that inside there. So for example, if you want to compare an employee object, employee data object to a string object, like you would, let's say you had an employee ID or no, let's say you had an employee data object, a person essentially, and you wanted to compare that person to see if they are like first name and last name John Johnson, then what you can do is you can implement it in a way so that you're comparing that to a string. So over here it shows you public class employee data implements comparable of type string. So you can do it that way. That way you can compare things that aren't necessarily the same type. But it makes logical sense because if you want to compare that person, see if they are John Johnson or Sue Ingram or something like that, you can do that. And then we have some more participation activities here. So an interface contains method declarations as opposed to method definitions. An interface cannot be instantiated. Then a class may not simultaneously extend a class and implement an interface. These, just follow along up here. You've got your answers. Like, for example, the class may not simultaneously extend and implement, but that was kind of the opposite of what we were just talking about. So that should be easy enough to find out. And then over here, we're looking at enter the, let me go back. Yeah, enter the output for sorting an array. So this is easy enough. You're just going to go in here, look at it, understand how it's implementing everything. And when you do a start, you're just going to go ahead and run it using this input and see how it acts and then put in what the output is. One thing to keep in mind is after every line, because you're using, I think, print lines, and yeah, you're using print lines, just remember there's a carriage return after each one. When I say carriage return, I mean a a hard return with hitting the return key. So even on the last one, you'd hit that enter after it. So it will flag you if you haven't done that. So anyway, I hope I've been coherent enough in this explanation. If there's anything you didn't understand in this lesson, please reach out to me. I'd be happy to help you out. Just send me an email and I can set up a Zoom session. So otherwise, I will see you in the next lesson. Have yourself a great day. Aloha.